Welcome to the Build It Better podcast. I'm Robert Johnson, your host, and we are thrilled to finally make this happen. For those of you that don't know, we've tried to record this, I don't know, 3-4 times already. It's been ridiculous, but we're glad to have finally put this together. Our guest is Jonathon Sipe. Jonathon is the principal and founder, I would assume even, of New Beginnings Engineering. Am I correct there?
Yes, you are correct. Yes,
awesome.
I am the founder. Yep.
Jonathon, why don't you start? First of all, thanks for coming on. I apologize for the delays, but start by introducing yourself and telling us a little bit about you and your firm.
Yeah, so like I said, you said I'm a founder and the principal structural engineer for the company. I founded the company roughly about 8 years ago. I actually used to be a former bridge engineer, actually. So I used to design bridges and highways within California. And so I decided to open up New Beginnings Engineering because I saw that there was a need in the residential and commercial market for solid structural engineering. And I had done a lot of large designs for KB Homes, Lennar, Richmond American. So I was a design engineer years ago for all those big builders. So very used to their needs and their, what they need and the wants. So New Beginnings is a full service architectural as well as structural engineering firm. And so we do a full cradle to grave package for the business owner or the homeowner. And so we do full architectural design, structural engineering services, mechanical, electrical, plumbing, your energy compliance as well. So like I said, we get your package together. We sit with you during the architectural phase. We sit with you through structural engineering. We make sure it's value engineered, right? Because we don't want you to spend any more money in construction than you have to. And so we'll also permit process your package, right? We'll walk it into the building department, process it. And so once you get your permits, we don't go away, right? Because you're going to go into construction. Your contractor may have questions. And so we're going to be there to answer his questions as well. So we really are there with the owner or business owner from start to finish.
What an interesting way to back into it from, I would say heavy structural engineering with heavy highway and bridges, et cetera. Residential. You've also done some commercial as well, correct?
That's correct. Yeah. You've done family buildings, commercial buildings. Yeah.
So were you primarily involved with timber? Structural steel kinds of things? Was there any emphasis on light gauge steel in the early years?
Not really. As you know, timber, it was timber, coal forms. It was timber and structural steel and concrete and masonry, right? Those are your four avenues to build off of. So no, it wasn't until the last 3 years ago is when we really were thrusted into it. Yeah.
And what was it that made you make the step into and interested you in the cold form steel piece?
Well, to be completely honest, there was a company out of Australia that reached out to us and said, "Hey, we want to bring cold form steel residential presence into America." And I said, "Well, that's interesting." And I obviously, as a structural engineer, know light gauge steel, right? It's done in the commercial industry. But to do it in residential is interesting. And so we started diving into it. We actually took a 4-month, I want to say we kind of took a 4-month slowdown of work. And my engineers, my team, we all huddled together and we said, let's research this code. Let's research how to engineer this in residential design. And so we really became experts within that. And it wasn't until we started going to IBS and we got in touch with FrameCAD. FrameCAD really closed the gaps that we sort of had, moving into this arena. And And we saw, and once we saw the benefits versus timber construction for the last 20 years, um, it was like a no-brainer, you know.
And it's interesting that your introduction came from Australia. Frame CAD being in New Zealand, heavy Australia heavy. I learned and saw it more in Australia as well, and thought, man, I thought everything was being built with light gauge steel in Australia, and certainly more residential is being built there than being built here.
Yeah,
But it's interesting that they had experience in Australia building with light gauge steel, I would assume.
that's correct. Actually, both Australia and New Zealand, they were doing both countries. So,
Okay,
yep.
so yeah, and the push being, and in Australia, at least from what I have found, they're building everything with a single profile. There's not a lot of dual profile 5.5 or 6 inch on exterior or load bearing
Right.
and the other. It's just a single profile system,
Mhm.
which I believe that you have kind of stayed within when it comes to residential construction. Am I correct there?
Yeah, I mean, well, a lot of times we do try to do a 3.5 stud for the interior walls, right? But yes, for Australia, it's typically just one profile because I think some of the um, climate and external demands are different down there for the homes, and correct. So seismic, wind, snow, things are just a little different, and the building code in general, right? So it's different here.
So
So
I mean, now, so are you then sticking with the traditional 5.5, 3.5, 5.5 at exterior wall thing? Are you, that is what you're designing to?
yeah, for the most part, and what's driving the 5.5 exterior is not so much the structural capacity need, but more the energy compliance, right? Because
Yeah,
that's kind of what's driving that sticking to the 5.5 profile.
gotcha. Okay, which is what I hear often.
Yeah, yeah,
Now that we're seeing a lot more of the modular uh, aspects coming in. I mean, I've been inundated with inquiries from modular builders,
oh, for
and
sure.
the modular guys are trying to go to that single profile as well. But that's where they're always going to get stuck, is when it comes to the energy compliance piece of it.
Percent. Yeah. I mean, if you're in Mammoth, California, it's going to be pretty challenging to do 3.5 exterior, right? There are products out there, but by the time you spend the money for some proprietary insulating products, I mean, you might as well just cold form to a 5.5 stud.
Yeah,
You know?
yeah,
Yeah.
I get it. Very interesting. So I know one of the customers that very well, that both of us know
Yeah.
very well,
Yeah.
and
Yeah.
you do, if not all, at least the vast percentage of their stuff, and it's a single family residential methodology.
Correct.
How's that going? Are you getting? Is it getting legs? Do you feel that it's gaining any ground in this timber rich residential world that we live in?
Oh, absolutely. I mean, I don't know if we can just broach the name
Oh, we
and
can
throw it.
certainly. Yeah, yeah. I just was
Yeah.
throwing you a softball, but it's Frame Up Now, who has been Roger and his team, and Roger's been a previous guest on the podcast.
100%. No, Frame Up Now has made significant progress. And I don't just say that because I'm their sole structural engineer. I say it because seeing it from the internal workings and working with them to help build their systems, we actually have customers. There's lots of customers that are coming and requesting the cold form steel over timber. And the process that Frame Up Now is doing, the single family resident production model, how they're doing it has never been done before. And it's kind of funny. Sometimes when I've done work with them, I have my mentality of everything's very custom and everything's very, and that can be so much more cost inefficient. And so Roger really has a way of doing it that I have to change my way of thinking how to approach it from the engineering standpoint. But yeah, it's absolutely gaining ground. So,
and I agree. I'm seeing the same thing. It is a very slow. It's a very gradual
yeah,
adapting of light gauge steel in residential construction. Because you've had some dealings in the commercial world. And we've talked about this before in other platforms that we've spoken at. But the MEP people primarily see light gauge steel as a commercial way of framing, a commercial way of building,
yeah,
and commercial pays more than residential. And so the MEP folks tend to price their working with cold form steel more expensively than they do with wood,
100%.
which absolutely is not the right mindset.
No,
Especially with the things that you can do with the softwares now and FrameCAD and others like it, that where you can put holes wherever, service holes wherever you want it. You can put bracing at diagonals. You can it's amazing to me the lack of knowledge that's out there from especially the residential guys. And
there's a lack of knowledge too, Robert. There's a lack of knowledge not just from the builders, but the technical community as well.
yeah, yeah.
Right? Because we've actually have other clients that now they're bringing their engineered plans in cold form steel and say, Jonathon, can you take a look at this? It looks a little over engineered.
Oh, you said my buzzword I was going to next. Over
Yeah,
engineering is what you typically see.
it is. And so like one plan set came across my desk and they have floor joists. I'll just give an example. They have floor joists spanning 10 feet, a very simple span, and they're calling out 14 gauge floor joists. And I'm like, holy cow, that's way overkill. And I think it is this inexperienced, not comfortable feeling in that design. And so we're now helping out other clients that have already have engineered plans, and we're value engineering it. We're dialing it back to help them out.
Yeah.
And FrameCAD software is an amazing tool for that. So.
And you do function. You have the software. You use the software for design and for analysis. Let me dive into that for a second. So, when it comes to the software, what is it that you still have to do? I get this question all the time because, and I think you understand where I'm headed with this. We sell a system to somebody and they get FrameCAD structure and FrameCAD detailer. And we tell them, and I'm going to do the air quotes, that FrameCAD structure engineers your building. It takes care of the engineering of while you're doing your design.
It does.
Okay. But if that's the case, a lot of people think, oh, I don't need a structural engineer. All I have to do is have somebody, I can do these drawings myself, send them to them, and they can stamp them. And I should pay pennies on the dollar, pardon me, from what it would cost it for me just to have you do it.
Yeah.
Explain to me why that's not the case.
Why that's not the case where it's acceptable to do that?
No, why it is not the case that I can design my building in FrameCAD structure and only pay you pennies on the dollar to stamp it.
Well, with FrameCAD, because first of all, there's two sides of the coin here. One, there's a professional responsibility as an engineer, and it's called responsible charge. And what that means is, I've never stamped something that was already engineered across my desk, because if you don't have that involvement, that intimate knowledge of what was done and where things were placed, it's actually against the engineering code for the state for us to do that. Now, there are engineers that do that, but they shouldn't be doing that. So there's that aspect. And then the other aspect is sometimes with any software, there's always, whoever's modeling it might not know exactly where the load paths need to go. And so having that intimate knowledge of FrameCAD, um, like any software, I'll be honest, every software has its limitations. I'm not going to sit here and say FrameCAD is 100% true. I won't say RESA is 100% true. I won't even say AutoCAD's 100% true, right? Everything has its intricacies, and having a trained professional working with it is key to know that, because all it takes is, a connection that wasn't done right on a floor joist, and you can have catastrophic results.
Well, what I typically have seen is I see kind of what we've already alluded to. For those that think and feel like, oh, I can have my person do the model, and you can have an in-house designer do the model and then spin that model to you and have it analyzed. I understand that. But what typically happens is you have something that's over-engineered because they're not engineers. They're going, okay, they're like, well, this is saying that I only need one stud, 16 inches on centers or 24 inches on centers. I think it needs to be 16 on centers, and I think it needs to be 14 gauge.
Right.
And so
Right.
it just gets out of whack. And
Yeah. Yeah.
I saw that for the first time after I had a very well-known structural engineer that does light gauge steel that I had used on previous mid-rise construction projects.
Mm-hmm.
And I spun a set of drawings to have, just to kind of get a second opinion with somebody that was an structural engineer that understood panelization, understood the software. It cut tens of thousands of pounds of steel out of that structure.
Oh, absolutely.
I mean, it was so much money that it was ridiculous. And so I think the early adopters probably ran into that a lot, and prices were, buildings were overpriced, and it made it tough, maybe tougher to have people make that jump from wood to steel.
Yeah.
Do you find that to be the case still?
Yeah. I think there's still that over engineering going on. In fact, we had a set of plans come across my desk yesterday that another modeler did a model just like what you're talking about. I think they need to be, such and such center on center, and it was a single story house, and he had put the studs at 8 inch on center, and like, so I agree with you. We are still seeing that. So that's why you just need to have an engineer look at it. The one thing I did kind of want to side note or caveat here is, and it's a very important educational component to engineering, is if you're a business owner or a homeowner or developer and you're looking for an engineer. Not many people know this, but the stamp that I stamp the plans with, or the stamp that you go hire somebody else to stamp the plans with to turn them in, my stamp looks the same as their stamp. But, you can go get your engineering license in a multitude of disciplines. For example, you can get it environmental, you can get it into construction, you can get it into tree hugging. I mean, to be facetious here, but there's so many different things. So I always caveat to clients and business owners and developers, I always say, ask the question, when you're hiring somebody that say they're a structural engineer and they're stamping your plans, ask them, what did you do your license in? And if they don't say structural, they're not a structural engineer, because they're trying to get into that role. They didn't do the training, So for example, I have my degree in structural engineering from UC San Diego. I did my license in structural engineering. So that's the continuity that you need to make sure to look for. So
yeah, the other thing is we preach the benefits of the light gauge steel and building in light gauge steel, and it's one thing to have you as a structural engineer do the structure, but to be able to do that and move all those benefits all the way through your foundation, because now you've got a lighter weight building, your footing,
right.
It gets into concrete savings, rebar savings. structural steel savings. Those are all things that a true structural engineer is going to pick up. Somebody that is either going to be, and in my world, I would prefer to have the light gauge guy be the EOR, or the engineer of record, on the entire project, to be able to incorporate all of those efficiencies all the way through to help bring that savings. But so let's talk about this. So what's so different when you're engineering with light gauge steel as opposed to wood? What are some of the things that are challenges that you faced initially?
Some of the challenges initially were just, sometimes you can span long distances with cold form steel. But I like to talk more about the benefits of cold form steel over timber that we like. And obviously it touches with the over engineering. For example, timber and cold form steel prices, as you know, are roughly the same now, right? Cold form steel is actually starting to drop even more now. And so, I talked about this with somebody else, and when we structurally engineer design, let's just take a wood beam, timber, or all the studs you put in a house. We have this thing called utilization of its capacity. And what that is demand over capacity. So for example, if I need a beam that'll hold 2,000 pounds, I'm not going to design a beam where it just barely holds 2,000 pounds, right? I'm going to design it, it's like an elevator. There's a safety factor involved. So with that utilization, we always want it under 1.0, but we don't want to take it all the way to 1.0 because it's too scary for engineers to do that, because we don't know the wood properties. It could be knots, it could be green, right? So we stay around the 70 to 75% utilization for that. And so what ends up happening is you're throwing more material into your build, right? You're not pushing and using all the capacity of the wood. Now, steel is a homogeneous material, we call it, which means the properties are the same in all cross sections of that steel member. So I can go to 90%. I can go to 95%. So we have a material that's the same cost as timber or less, and now I can use the properties 20% more than I can timber. So what's that going to result in? That's going to result in a lower construction cost, right? Less material. So, and not to mention, so that's one massive benefit. And then the other benefit we see all the time is we have a home right now that we're jumping into. We have this homeowner. He actually engineered a 5,500 square foot house with a basement in Newport Beach. And he had it all permitted and engineered out of timber. And they said, hey, Jonathon, I really want to look at cold form steel and switching it over, which, by the way, is not that hard. You just do a material change with the building department. It's very easy to do. We do it all the time.
Especially if you're already designing in light gauge steel in 3.5 and 5.5. There is no dimensioning differences inside. So
right, no dimensioning differences. But what's nice about switching over is when you have a very custom build too, you have a lot of vertical offsets, right? The floor, people like to get very creative in the architectural component look of the house. And so, as everybody knows, if you were to build a wood wall, it warps, it's twisted, it does, so by the time you go 10 feet up and you've got all these vertical offsets, it's nice to know if you had cold form steel, everything is straight and true and everything lines up perfectly. So it's a massive benefit in construction, because if things don't line up in the fields, you end up with delays. You call your engineer, hey, what do we do? Provide a fix. Once you get a fix, get it approved by the building department to approve the fix. So, that's a big benefit as well.
And they're doing that kind of stuff is happening, live in the field, where they're having to cut and build and do those things, where in this, all of this is done in a factory.
100%. Yeah.
It's all been fixed and decided and caught, and long before it's ever been put, screwed together. And so I tell people this all the time. We wind up spending more time in design because of the clash detection, of just the things that are done. But takes so much time out of it in the latter stages, in the construction stages.
That's correct.
So it speeds it up considerably.
Which is labor costs, right, Robert? That's like
Correct.
major labor costs. Yeah.
Yeah. Yeah. That's it, it is funny. And having these conversations with people 3 and 4 years ago, and having these conversations now, I'm seeing that that message is getting through. When I first started talking to people about converting a structure from wood to steel, and you would spout all these benefits, people would kind of roll their eyes and be like, I tried to build a house out of metal studs 25 years ago, and I did it with a chop saw on site, and so they think they know it all until they really see the entire process go together. And I will continue to say, knock on wood, I have yet to have somebody that we built something for has not said to me, why haven't I been doing this all along? I mean, this is ridiculous. I'll never build another way.
100%. We haven't had a complaint as far as I would rather go to wood. Another benefit with it as well is we have a lot of societal changes out there, right? For example, kids are getting divorced, or kids are coming back home from college, got to live with mom and dad, or you're taking in mom and dad to live at the house. In fact, I was talking with one of my employees earlier today. I said, Lennar and KB Homes, all the big builders, they saw this years ago. I mean, you have these next gen homes, you have all these homes that started putting apartments on homes. But, if you have a house that's already built, so you have equity, you have a lot, but hey, let me put up an ADU. But what happens when, your mom needs to leave where they're living? You only have 4 weeks to figure out where to put them. I guarantee you're not building an ADU out of wood in 4 weeks. But you go cold form steel and panelization, and it's going to be built stronger, and you can get that built in 4 weeks, and you can accommodate the societal needs with that,
Yeah, and then let's throw in there the things that are happening environmentally, especially Southern California. Fires. I mean, fires is a huge. I just saw an article that Build Steel, I think, put out. You may have seen it. It was on LinkedIn, and they were talking about the how prevalent fires are now in multifamily construction.
Oh yeah.
And it's when people talk to me about it, I say, I have one question. Would you build, if you had a choice of building something for your loved one that you could put a match to and burn down in 5 minutes, or something that's going to give them some time to get their stuff and get out of there, what are you going to do? People haven't thought that way for ages. It's just been, let's build the cheapest way possible. And they've got it all figured out. Their pro formas all work. They know they can make money doing it this way. So why should I change?
Exactly.
And now they're starting to understand the benefits of your insurance is less, pests, mold, mildew, all those things that wind up getting just really, it takes that completely out of the conversation.
And on top of it, it ends up becoming quite a potential of jumping into the real estate revenue game. So, for example, years ago, California passed a state law to be able to put an ADU on a lot, right? Well,
just happened here in Phoenix not too long ago. They approved the same kind of thing.
Yeah, absolutely. So you can rent it out for a little extra income in your backyard, right? Well, now they've taken a step further in California, and now you can split your lot and independently sell that. That was just passed about a week ago. It is. So not only can you think to yourself, hey, how do we come up with some fast income? Well, okay, why don't I can build a house out of cold form steel, of course, within the setback rules and the building separation rules of the lot, split it, sell it, and there you go, right? You don't have to, wait 6 months to a year to get it built. So
yeah, that's actually very amazing that I had not heard that yet. ADUs has been gaining ground over the last year and a half or so.
Oh,
Are
it's
you
been
get
well,
are
it's
you
been
get are
well.
you getting that knocked? I mean, you getting a lot of that kind of work coming your way?
We are, in fact, I want to probably say 40% of our work is ADUs, you know, because a lot of cities are now recognizing the need. And I'll take, for example, one city in LA used to be like an 8 foot setbacks, old school building on a lot, 8 foot setbacks. Now changes to 4 foot. They changed the 10 foot building separations to 4 foot. So it makes it more available to people, and then the allowable square footage has gone from 600 square foot allowable ADU to 1,200 square feet.
I mean, that's the
So
size of a single family home in some places.
it really is. It really is. And so it's definitely opening up a lot of possibilities. Like we said, either the revenue side for folks or, personal family needs to put somebody back there, right?
Yeah. Okay, let's stick with residential. Affordable housing. Affordable housing is another huge buzzword that's happening right now.
Yes.
Veteran housing, homeless housing, or shelters. I probably get 2 to 3 calls a week from people that are looking to do, a 12 by 10, and they want to build 100 of them at a time.
Yep. Yep.
This is a good. This is also a good fit for that.
It really is. It really is. Yeah. Yeah. It really is.
Weight,
We have a couple of
speed.
clients that are doing that right now.
Well, and to me, it's the speed to market thing. You can, and especially set it up in a factory. Now, the weather's beautiful in Southern California, other than a little rain here and there, but they build stuff year round. But you get into some of these more harsh climates, and being able to do these and build 90% of these things in a enclosed manufacturing space is a tremendous advantage.
Oh, 100%. How are you going to dry your wood out in Minnesota if you haven't completely framed and enclosed the house by the time the first snow hits?
Yeah, we were just talking about that this week. Typically, even here, I'll use in Phoenix, and Phoenix is very dry. So you see these in these big subdivisions where they're building, and they'll just go out and they'll drop stacks of lumber, plywood, all kinds of stuff. Okay, it's beautiful. You go out, you're getting ready to frame, you cut the bands on the wood, and you go to framing.
Yeah.
It rains, it doesn't rain. It sits out there, you get it framed, and you wait. And when you get ready to start putting drywall on the inside of that thing, it is a nightmare.
100%. Yeah.
Everything is gone back to nature. It's warped. It's twisted.
It's swollen. You don't have a flush surface for drywall. Yeah.
Yeah, and level 5 finishes are now a big thing. People like a level 5 finish, a real smooth finish. Well, you can't do a level 5 finish unless you've got a straight wall.
That's correct.
I mean, you can. It just looks horrible. That's why we have got. Why for years you see this big thick texture on walls is not because it's cool looking. It hides all the imperfections in the wall.
Yeah, all the undulations. Yes.
Yep,
Yeah.
exactly.
Yeah.
What are some of the misconceptions of constructing a house in cold form steel when it comes to cost and strength? Just some of the things that you've had to fight against, what people thought about cold form steel.
Well, definitely the biggest is a misconception on cost. I think that is always the number one topic that comes up with the clients. Like, wasn't it more expensive? Isn't it, more costly? And so you have to kind of rein them in and educate them. And like, for example, the labor aspect, you get a couple frame. Let's walk it through really quick. So, let's say you're gonna frame up a cold form steel house. I mean, frame CAD machines, hell, I don't remember the recent number, but those machines can spit out your studs and your cold form steel members in an hour or two, right? And then you get that shop can panelize everything, in half a day or less. And next thing you know, the panels of the house are on a truck coming to your house. Whereas, the labor involved with, cutting the ribbons on the lumber, framing it up, tilting the walls up, it's just much longer. The other misconception is obviously well, isn't it built with screws? I mean, God, that's got to take forever to screw. And, it's just screws are only one of many fasteners. They have a lot of pneumatic gun solutions to that actually work faster than a nail gun. And you're just going go with the speed of studs, and it's like no different than wood to wood and out in the field. It's really interesting. We're always trying to visit manufacturers, that manufacture the steel. And I can tell you probably 50% of the time that I go visit them and talk to the owner of the company, I look in the warehouse and where is everybody? And I said, well, they said, we only bring them in when we need to do a job. And since we have the frame CAD machines and panelization doesn't take that long, you don't need a crew full time, right? So it's sobering. You have to kind of put that in perspective.
Yeah, I actually, and I'm in a lot of factories, and I actually heard that. I actually asked that question. I was walking through one, and there was the machines were running, and they were stacking some pieces on some carts, but there was nobody assembling wall panels, and I was like, why did you not? And they said, well, we have to, as fast as the machines are, which they can run 2,000 to 4,000 lineal feet of material an hour.
Yeah.
You can put together. You can really spit out a lot of steel.
Yeah.
But as fast as they are, the assembly of the panels is so much faster that they're having to manufacture pieces 2-3 days ahead of time so that they can build up enough that when their assembly guys come in, they can work for a couple of days.
Exactly.
And then they're gone. Well, then it's just sitting outside waiting for something waiting for a slab, and then again, it's the same thing. So.
And one of the biggest misconceptions about it too is a lot of people look at the term modular and the term of panelization always has a negative connotation, because old school way of thinking is a mobile home that's a modular dropped in. It's so different now, right? This is actually real walls being built, right? 5-inch, just as stronger than timber construction. But yeah, it's funny. You have to change people's mindset a little bit, because
I grew up in the manufactured home era, and so when it was, 1.5-inch wall, it was, built out of a 2x2 or something,
Yeah, exactly.
It was crazy. And so I kept thinking, man, I don't want to, why would I want that? And you're going to build a 4-story by stacking those on top of each other? Yeah, I don't think so. So you're right. There is some educating the public that needs to happen. But we're doing that. You're doing that. Man, listen, it's been fantastic. I can't believe we've already blown through our time.
Oh, yeah.
If people have questions for you, and I'm sure they're going to, how can they reach out to you?
Well, they can reach out through my phone number or email. I don't know if we want to say it here.
Absolutely. If you want calls, share it, and we'll throw it in a blurb at the bottom at some time.
Yeah, so anybody can call me. My number is 949. That's 397-5191. Or they can throw an email inquiry out to us at info@nbesocal.com. So it's our initials, New Beginnings Engineering. It's nbesocal.com. And one thing I always like to inform people is we're not just a SoCal-based company. So we're licensed.
Thank you. I was going to go there, but yeah, thank you.
Yeah, so we're licensed in over 20 states. We're designing homes in Florida, Texas, Hawaii, and now we're actually have a client down in Brazil. So we're now doing international work because they have a housing need down in Brazil. So, and they're using frame CAD machines to take care of that need. So,
very good. Again, man, thanks a bunch. I'm sorry it took so long to get this together. We're going to do this again. And I may do one that we get 2 or 3 engineers on and let everybody kind of butt heads on it. But we'll come up with something fun. But yeah, so I appreciate you coming on. Something I like to say when we get to the end is we've all built it the old way. Now
Yeah.
let's go build it better.